Hi, everybody. I'm Miles Ward. I'm CTO at SADA, and I'm super excited to walk you through Anthos in production. It's a set of architecture reviews for the real world deployments that our team has done with Anthos in the wild. We're going to walk you through step by step how those infrastructures work, what problems customers faced, and how Anthos was the solution to those problems, and what benefit they earned as a result. I'm really excited to unpack what Anthos can do for businesses and show you some of the newest features in it because it's really come a long way since its launch. So I spent a bunch of time with one of my heroes, Vince Cerf. If you don't know, he's the inventor of this thing you've heard of called the internet. And I asked him a question like, how do you build an internet without an internet, right? I would assume if I had something scary like that to design, I'd be going to Google and searching for guidance, maybe white papers or things that I could be inspired by. His comment was, no, it's not so hard to build an internet. Reality is we had networks before the internet, is what he said. And the IBM network or the DEC network or these other pieces, they just didn't interoperate. There was no way to connect them in a way that was standards compliant, in a way that enabled the proliferation of capabilities that you now see as a part of the real internet. And his comment was, why don't you guys have an intercloud yet? Isn't that what you're working on? And I was like super blown away because I know customers really want that world to exist. They need the benefits of a cloud provider, but they need it to work everywhere. They need it to be that way in their data centers, out at their edge. They need it to be interoperable across the different cloud providers because they're very different. So I was really inspired by the concept of an intercloud. And I'm excited that from what I can tell so far, Anthos is the intercloud, the standard that is going to allow infrastructure and operations and development teams to align on a platform that enables interoperability and speed. So to talk through the case studies that we're going to focus on, I'm really excited to walk through these three different customers of ours, each with distinct use cases, and unpack how they use this platform to take their business forward. Before we start on that, though, really critical to understand there are so many different parts of the Anthos platform, and it provides different benefits, often to different stakeholders inside your organization. So maybe your infrastructure teams or your procurement teams are just looking very basically at, I have two different environments. I want to be able to run both in our existing investments in on-prem infrastructure and also remote. Anthos takes care of that because of its ability to deploy on-prem on VMware infrastructure running anywhere. You also have operations teams and infrastructure managers trying to think through a reduction in complexity. If they have a system that's going to run on-prem and remote, it might today use totally different APIs. They're probably coming from different providers, whether that's, maybe your cloud for marketing is in AWS and your cloud for web development is over in GCP and your cloud for SQL Server is in Azure. Each of these different tool environments, they have totally different APIs, different rules, different certifications, different trainings. The complexity is really daunting. If you're a developer, this problem's only worse. Not only do you have to make sure that the thing, once deployed, can operate in these different environments, you have to be able to build it in those environments. So is the CI/CD tooling the same across the different clouds? No. Is the infrastructure that you use to be able to coordinate A/B testing or to roll back version? No. Like if you have different stacks running on different clouds, you are doubling or tripling or quadrupling the operations and development operations, DevOps, overhead for your applications. And all of those challenges fly in the face of what product managers and product owners are trying to achieve in accelerating the path to value. How do I get more features out more quickly? You have these requirements that keep ramping up around building a system that's more available, that costs less, that's more reliable, that's able to capture all of the unique capabilities that are present in the cloud providers. But if that takes longer, maybe that doesn't meet your needs. You really have to accelerate the path to value. And if you're over in finance, and you're trying to see the cost for this stuff go down over time, there is no clearer rule in procurement than thou shalt not buy from a single provider, right? Being able to take advantage of multiple vendors to consume the infrastructure that you need to power your business is a critical critical capability. So in order to do that, I want to talk you through one of the examples from one of our customers where time to value was really the critical issue. Hold on a second. Hold on. I'm sorry for folks on the webinar. I have a strange boss. Just hold on a second.
Miles, we have a board meeting in 5 minutes. I told them you put the whatchamacallit on the VMs already. What's it called? Tupperization?
You mean containerization?
Yeah, that's the stuff. Anyways, they told us we need to have everything on GKE by the end of the day, or they'll cut funding entirely. I would have told you sooner, but I needed to make sure all the pens in the office had caps.
Okay. So everybody, I have strange leadership. I was gonna show you how some of this stuff works anyway. I might as well just sort of do it for the boss while you're watching. Let's go take a look at what it will take to get our system migrated from virtual machines to containers. Containerizing our application. That's a part of using Anthos. I think we can do that pretty easily. This, if you look on screen, it says Looney Chat. This is an instance running our application. And let me tell you, this is a full-featured piece. I got all my requirements from that pony-haired boss. Basically, what he wanted it to do was say, welcome to Looney Chat. So that's what it says. Here's that application running on our virtual machine. We're connected to an external IP address. That's what allows us to see the app. Now, if we're going to containerize that, we're going to need to use some tooling. Now, let's see how we would do that. If I go here and I say, oh, wait a minute, look, this says migrating Linux workloads. That's what we're running. Here's this tool called Migrate for Anthos. But this seems, I don't know, this seems complicated. There's a lot of documentation. Maybe we can just sort of get it to go. So if I'm here, let's see what I've got around here. Like, oh boy, lots of, oh, even more. How about, there we go. Oh, what's in here? Migration code. Well, let's try to use that. So first, in our migration setup, we're going to probably have to use Anthos migration system. And that starts by creating or having a processing cluster. We've already set that up because I've been doing processing all the time. I can use gcloud to create a set of connections to that cluster. So here's a block that uses the gcloud SDK to connect to a specific processing cluster that's in the same region, US West 2, doesn't have to be in the same zone, and it's in our same project. So by connecting into that cluster, then now I'm able to issue it commands. The command tool that I'm going to use to issue commands is a thing called MIG control. That's for migration controller. If I go MIG CTL, now I need to create a migration source. So this is pointing at the virtual machine that we're going to bring a container out of, that we're going to convert into a container. So our source, we're going to create one. We'll call it my CE source. We'll do that in the project SADA Anthos next 2020. And we'll do that in the same zone as the virtual machine. So US West 2A. Great. So that creates a migration source. That's a resource that gets used by an actual migration job. The next step is to create a plan for that job. So you use the same tools, MIG control, and we want to do a migration. We're not doing anything weird. And we want to create that plan. We'll call it Looney Chat MIG, sure. And we have to tell it which source to use. That's the one we just created conveniently. And we have to tell it which VM to use. Now, conveniently, that one's called, you can see it up there, Looney Chat. And we have to give it an intent. And the intent that we have is to make an image because we plan to run it as a container. So if we run that function, Then it's going to create a plan for us to do the migration. Now, following a plan, we're going to want to execute the plan. However, to do that, we want the virtual machine in a consistent state. So we're going to stop the virtual machine to ensure that it flushes all of it, all the contents of persistence into the persisted disk and makes it prepared for migration. Stopping a VM instance on Google Cloud is pretty snappy, pretty fast. You can track the progress for that on the little alarm bell up here. You can see its little spinny wheel as it thinks through how to do it. So when that gets completed, this little green check will change. You can then start off the actual migration. So to execute the migration plan, we do mig control, and we'll probably call the migration, and we're going to do a migration that generates migration artifacts. Now, those artifacts are the markers and the files required to launch the container. So generate artifacts. Look, faster than I can type this in. The VM is stopped. So now I can run this function, and that runs validation checks on the migration that we've described. We're telling Anthos migrate to run, and then it will run through and process. Now, this takes all of about 11 minutes to complete. You can actually see the status of a function like that. If I go mig, mig control migration status loony, then it knows what it is. So right now we're at 13 seconds in, right? And if I run this guy again, 18, we're only at 2 out of 15 steps. So I'll come back to this. We've got plenty of material to walk through. I'll talk through another one of our customers. We'll see if we can get this completed so the pointy-haired boss gets off my neck. We were talking about accelerating the path to value. So one of our customers, Press Apart, they had a pretty unique challenge. Press Apart, they build high precision metal gears and parts for the medical industry, for the aerospace industry. They've built stuff for the space station, for SpaceX, micro precise gearboxes and motion control devices, super fine pieces out of titanium and exotic metals. Really an incredible business. All of this doesn't sound very much like cloud to you, does it? Press Apart has built its entire technology stack on Microsoft Access. And for those in the back row, that means that they might be running into some technology challenges because Access goes end of life near the end of this year. So Press Apart was eager to understand what a platform that they could bet on for the next 20 years looks like. I said, hey, I think the intercloud is where the market is going. I think containerized technologies and building modern applications in a way that allows them to be deployed anywhere is going to be an important part of any platform design. So we worked together with the engineering leadership at Press Apart to think through how we would deploy Anthos, one, in their local environment, because remember, it's not like a milling machine or tools like this really work that well in an office park downtown. This is in upstate New York, where internet connectivity can be spotty and where total bandwidth is relatively low. So they really needed a system that was going to be able to work offline. We designed a network and infrastructure architecture to deploy Anthos on one of our hardware appliances, a device we call the toaster, to allow them to deploy and design and build applications locally while taking advantage of public cloud infrastructure when and if they need it. That used F5's load balancers as well as the VMware installation onto bare metal infrastructure to allow easy deployment of their overall system. You can see an architecture diagram here of the IPsec VPN tunnel that was used to interconnect securely from their local environments into Google's public cloud for control. And then the deployment of the toasters, those are the two little Anthos boxes at the top of the diagram, that enables them to interoperate with their other applications on their local network and to allow them to have an easy, seamless management experience for the overall platform. The result is that they have a system that can be disconnected from the public internet while still serving modern, high capability applications locally from the toaster. That's a cool setup that really unlocked a lot of value for them. I take it from Robert Field. He's the VP of engineering at Press Apart. He says Anthos is providing the platform for the next generation of Press Apart's manufacturing control and coordination, where we need it now and where we might need it next. We're in gear. That's pretty great. That value proposition, being able to land all of the sophistication of a modern cloud environment, but where they are, to meet them where they are, is a critical part of what unlocks value in Anthos. Now, if you're trying to run, in a remote environment like that, and to do so quickly because you're on time pressure, that's one thing. But if you have to build an application that spans both locations, that really is high availability across a public cloud infrastructure and a remote cloud, public cloud infrastructure and an on-premise infrastructure, that's a different architecture. Hold on a minute. Hold on. I'm sorry. I'm so sorry, everybody. I'm getting another one. I have lots of bosses. Just give me a minute. Yo, boss.
So, Miles, what's happening? Yeah.
Not much.
So, in order for us to fill out our TPS reporting deal we just closed, we're gonna need to be a multi-cloud enterprise solution before the end of the weekend. So, yeah, you can do that as soon as possible.
Sundays, huh?
That would be great. Okay.
Oh, I have the best bosses. Okay. So now we're going to have to deploy LuniChat both to GCP as well as to AWS. That shouldn't be so tough. But hold on, we still have the other piece. We got to check in on our VM to container migration. Let's take a look at that. Okay. So this is we're back in the Cloud Shell terminal, and you can see that the migration status shows complete. You can see full details on that with a verbose command if you're interested. So that'll show each of the resources that were created. It looks like it took a couple of minutes after the create image resource happened for each of the individual controller resources to get produced. You can see there was like a failed scheduled warning. So it's great that having the automation for migration means that this isn't something we had to like plug into and repair as we're going. It's all taken care of by the platform. So the result now is this new installed container image that's in the gcr.io registry that allows us to deploy images. But first, we have some steps we have to do. This migration creates persistent volume claims and persistent volumes, and we need to clean those up from the processing cluster before we move forward. So first step in that is also back in MIG control. We're going to be doing a cleanup. So that's a migration cleanup from the one we did before. That's LuniChat MIG. And we'll make a backup just in case, because who in the world doesn't want even more YAML? So that cleanup and gets rid of the PVCs or persistent volumes that were present, and the migration is now complete. The other piece we're going to want to do is actually go get the artifacts that we constructed. So at MIG control, we do migration, get artifacts, if I could type right, from the migration we just did. And it will pull down the container image for the non-runnable content as well as for the runnable systems container. Each of those files are being pulled down from GS, that's from GCS storage. That's a part of the registry. And then in order to run this container, we're going to have to connect to the app cluster. So that's another connection. Let's do that in gcloud. So we're connecting to container clusters, and we're going to use the app cluster this time to do our deployment. So we make a connection to that. And then we use good old kube control to do a deploy of see, because you can see what got pulled down earlier. There's the deployment spec if you ls that's available here. So it would be kubectl apply f deep, that one. Okay. So if you want to see what that looks like, we'll go over to Container Engine. That's available here. Kubernetes engine now. And that's a whole set of clusters that are available. Remember, we connected to the app cluster. That's this one here. The app cluster is deployed again through the regular channel in US West. We don't really have changes to make to the cluster. We have a change to make to the workloads that are present. So the workload that we're talking about right here, LooneyChat, is still being deployed. We just did the click on it. Yep, here's the LooneyChat app that's online. Now it's online, but it's not actually ready to be accessed from the web. To do that, we have to expose the application. So you go to actions and then expose. We have to give it a specific target port, and we have to assign the load balancer that we're going to use to do the style of deployment that this is following. If you hit expose, and then you've got the app is now exposed as a service. If you go to the details for that, you'll see the external endpoint. That's the same address as our previous application. Remember, that was here, and it still says welcome to LooneyChat. But remember, I'm going back to the console now. On the compute engine side, if I go over here to VM instances, you can see that the original host that was running the application, that was called LooneyChat, is still offline. So it no longer the application is running on the virtual machine. Now it's running on the container, and it's available to run here. So if we want, we'll just sort of go make sure our boss knows what's up. We'll say LooneyChat is now a container. Thanks for that. And back here and run and good. So the boss will probably have no problem telling that I have met and exceeded his expectations. So we've been able to migrate from a virtual machine to a container pretty pain-free. Next step is to go back talking about some of those great customers. A company that really needed to run the same both on-prem and in a remote installation. So they needed to be able to run the same application in two places, not just be able to fail over between. That company's DriveTime. We worked together with them to build a prototype implementation in their on-prem VMware infrastructure. Much larger scale system, more traffic, and higher requirements around network availability. DriveTime, as you may be aware, the folks that have made it super simple to be able to buy a car online. They'll pick up your car from your house. They're the ones that have the vending machines for selling cars. So pretty innovative, pretty path-breaking business. And they work together with us to arrive on an architecture where you use the full capabilities of Anthos. That's not just GKE, but being able to deploy cloud run applications and monitor those applications in cloud monitoring. At the time we did this project, it was still called Stackdriver. Our systems enabled them to be able to connect their applications together using Istio by way of the Ingress gateway. But different than the previous version where we were built on F5, we had to do the custom work together with them to enable the NetScaler load balancers. So an important part of updates recently to Anthos is the increasing ability to handle your own load balancers, your either own hardware or software appliances. More and more of the deployments are using, either Nginx out front or the Seesaw load balancer internally. But for them, it was critical to integrate with their existing NetScaler infrastructure. So this platform enabled them to be able to deploy a system, one locally as well as remote, using the same Kubernetes infrastructure, and to be able to load balance that application between those two environments. The folks at DriveTime, particularly Zach, was great, described that Anthos delivered a reliable Kubernetes distribution in our complex local environment faster and easier than we expected, especially when compared to the experience of rolling our own. That's high praise because it really is a place where, actually, their use case is pretty close to what my other boss was just asking about, right? Like they had to deploy in more than one environment, be able to, well, why don't we just get done what Lumberg wants? Like, I don't want to have to be in here on Sunday. So in order to be a multi-cloud organization, we're going to have to deploy our application to more than one cloud. The only other cloud I've heard of is AWS. So conveniently, Anthos is now able to deploy to AWS. How many people have seen this feature? So let's take a walk through the steps that are required and do a deployment for our application, not just on GKE, but on GKE on AWS. Start of that, let's go see if I've got any code that makes sense for that. Probably something like, yeah, that might be a good start. we've built some shell scripting to simplify some of these processes. Let's use the handy dandy shell editor. I don't know how many folks have seen this either. It is such an easier way to interact between a terminal experience and a code management experience for building applications. But we've got two different one shell script is deploying the management for our infrastructure in AWS. And then a second one is deploying the cluster itself inside that new management environment. So to walk through, let's make this a little bit bigger. First, we're creating some local tools. We create a Terraform configuration that uses AWS credentials to be able to connect. Then we use Terraform Workspace and initialize our Terraform environment to be able to deploy that Terraform script that we've constructed. And then we create, and this is an important part of Anthos's design for AWS, rather than exposing the control plane to the public internet, it creates a Bastion instance that will create an SSH tunnel through to be able to execute cluster configuration commands. So we'll start that tunnel, and then we'll get the credentials on the other side of that tunnel for interacting with AWS. And that's what allows us to start issuing Kubernetes commands into our newly constructed cluster in AWS so that we can do our deployment. So if I go to the terminal, first part is pretty easy. We just run the cluster management. See, and this script, again, is building an SSH key. It's creating an S3 bucket where we're going to hold our information, just writing a series of Terraform files, doing and downloading the individual modules, as well as initializing Terraform so that it can start to take the actions on the AWS side that we need to build our systems. So after we do the deploy management shell script, it's going to kick off the Terraform initialization. This stuff takes several minutes. So let's talk through one more customer case study. They were really looking at how to manage operations complexity. And for them, the complex piece was that they'd already deployed quite a bit on Azure, but wanted to be able to run containers in an on-prem infrastructure. So it's kind of a migration out of cloud use case that Anthos enables. So that company's Epicor. Epicor builds an incredible ERP system that enables businesses around the world to be able to better organize and orchestrate their infrastructure or their business. But Epicor had problems organizing their infrastructure. They looked at us as a way to unlock the applications that they were building in Azure for deployment in GCP. So just like you saw before where we migrated an application from a GCP virtual machine, we used the same Anthos migrate tooling to migrate from an image that we built on Azure and bring that image and deploy inside of a Kubernetes cluster managed by Anthos in their on-prem infrastructure. So that really simplifies the process of moving from totally diverse workloads, right? There are Azure tools for these kinds of things. You can look at Azure Stack or some of those other pieces, but the footprint for those are so substantial. And the timeline required to get those online really, really prohibitive. The folks that we work together with Epicor were able in just weeks to work together with us to do full requirements details, to get the deployment done, to have the migrations, pull their application images over, and to run those applications in their environment. The folks at Epicor, particularly Ethan, they said Anthos migrates a good fit for customers that would like to modernize low maintenance, non-critical legacy applications by integrating them seamlessly within a cloud-native platform like GKE. Anthos Migrate reduced the burden and resource investment in the migration strategy and allowed our engineers to focus on critical tasks. That's one of the key points in this. Everybody can do this technical work. Right? Like you can go find the instruction manuals on step-by-step buildup of containers or moving images between clouds, but having automating tooling that simplifies that effort just goes a long way in reducing your risk to taking some of these experiments to see if other platforms or other environments are just a better fit for your needs. So, you can see now that the new instance has been deployed in EC2. It's at a specific IP address. It has we have now the ability to manage that cluster. But what we need to do next is to deploy the cluster in this management context. So in order to do that, we're going to run another shell script called deploy cluster. I'll show you what that looks like in the editor. This is the deploy management shell script that we ran first. Here's the second one, deploy cluster. Conveniently, much simpler, few less lines. So here we're just using Terraform to output a sample cluster environment using that Bastion host to proxy into running the kube control commands that we need to deploy our cluster. So let's go run that, show you what that takes to look like. Now, part of that, because it is doing the deployment onto instances, it's completely constructing the Kubernetes infrastructure. Remember, we've gone from nothing in AWS to being able to just have this deploy. This command here will run, and it looks like, wow, it happened super fast. We only did these sort of two pieces. However, we have to stand up some instances and turn on other pieces. So it takes a little longer than you might expect. Let's go into the console, and I'll show you what it looks like on the AWS console side so you can see how that all works. So to get to that side, we are going to log into AWS. We go to our console here, and then it's going to say, hey, are you sure you want to get to US East? And I say, I totally am. Here's my handy username. And then here's my password. Oh, look, I've saved it. Look at how good that is. Oh, I bet you that's the wrong one. Don't be fooled. And then as we log into the console here, you can see in the management console on the EC2 pane, if these are the virtual machines that have been constructed to build the cluster that we're going to use for our application in AWS, control of that happens on Google Cloud Platform. So because it's Anthos, this is all centrally managed. And you can see this cluster here, it's almost ready to log in. Here's this O4C 6EC. Now, in order for the application to know which subnet is going to have the load balancer that it uses to expose or to create access for that application, we have to actually pass this value through in a tag. So if we go over to the EC2 management, that doesn't happen at the instances, it's a tag in the network. So we'll go to VPC, that's down here, and we'll go to our subnets. And you'll see that the deployment has created several different subnets, but we're interested in the public one because we're trying to expose an application. If you look at the tags that are available on the public one here, we'll edit it so you can see them more easily. It has the name of the cluster that has been built, but we're actually trying to point back to the cluster that's actually running our workload, not the control plane cluster. So if we go here to Kubernetes, you see this O4C is the same number as the cluster that we're building up. So that needs to be marked as a shared cluster. That's what the marker that it's looking for. We'll save that change. And then that makes it so that when we log in, we'll be able to see that cluster in the workload manager on the Google Cloud Platform side. So over on Cloud Platform, we've run our login shell script and created this login token. Important that you still have those bytes. So let's go get the login token here, copy that. Now, in order to log in, you simply use the login button, pick token, paste your guy in, and then you're able to connect to the cluster, and you'll see the status of that cluster change from not green to green. Green is for awesome. So now we have an Anthos cluster running in AWS, and we have to deploy our application, right? So it's not just enough to have a cluster to deploy to. Now we have to be able to actually deploy. So in order to do that, we have built a couple of other important enabling tools. So we'll go here, and then you can see we have just the actual application YAML file. That's all we really need, is to be able to do the deployment that targets the LuniChat application. We're going to deploy that app again by using our Bastion host connection, and we're going to send a kube control command over that connection to be deployed into the AWS cluster. So if I run this command here, we'll get to it marks that it has created the LuniChat AWS deployment. It's set up the autoscaler. It's created the service. So now if I am in and I go over here to our workloads, I'll scroll down here. There's app LuniChat is in the default namespace and it's deployed. We should see LuniChat AWS and it's still coming online, but there it is running here. So we'll run a refresh. And now LuniChat is online and deployed. So in order to see, here's the LuniChat version deployed on AWS. And this right here at the bottom is the load balancer that was constructed. Now it can take a little bit for this to deploy, but if I open this up in a new tab, you'll see here that it's going to redirect us to where the load balancer is. And then you'll see our LuniChat is now a container. Now, what we want to do, again, is what we really want to do is show that it's in AWS. We got to tell the boss. So go over here to the admin panel, do our thing with the password. Yep. Say, yo. All right. So now, if I go here, you'll see my message to Lundberg so that he knows that the application has been complete. But critically, if I go back to our other location, remember where the other app is running? Every one of the versions of our application is synchronized. So now I'm operating this device from our GCP installation, and it shows the same data as the one that's running in AWS. That's a synchronized application coordinated across two different public clouds. So we were talking about the great work that we had done together with Ethan at Epicor. Really excited about that use case. And this is the spot where I get to jump into the demonstration that I was actually here to walk you through. You're going to have a lot of fun with it. Hold on for me 1 second. Just 1 second.
Yeah, let me get back to you about it. Hey, Miles. Hey, what's up, man? LuniChat. That app is incredible. And multi-cloud is incredible. But like we're working with the most advanced technology. We're working with Google Cloud.
Yeah.
Don't you think we need a moonshot? Like, I think we need a moonshot. You're working with Anthos, right? Like Anthos, it's the thing. It's all over the place right now.
100%.
What could be a moonshot? Like something really big with Anthos. Wait a minute. I got it. We got to put Anthos on the moon. Like that's a moonshot. That's gonna be incredible. That's gonna be incredible.
What are you talking about?
Wow, we got to put Anthos on the moon.
I cannot put Anthos on the moon. Like, boss. I know you're not supposed to say no to the CEO, but like, look, like, hold on a minute. I'm getting another call. Who is this?
Miles, hey, this is serious. We need solutions.
Sure.
Is it even possible to send a message to these aliens?
Like what aliens? What are you talking about?
You know, we have aliens on the moon. Is it even possible to like send a message using your message app?
Yeah, you can send messages, but like, what are you talking about?
We need to tell them that Anthos solves multi-cloud with panache.
Sure. Yeah, I'm sure. Well, you know, where there's a will, there's a way, right? Look, I can't pull a rabbit out of a hat. I'll see what I can do. Why is the ancient aliens guy sending me a chat message? Hold on a minute. Is this a live stream of the moon? What? Hold on. Everybody just bear with me. This is some somewhat unusual circumstances. Maybe we can deploy the application to the moon. Let's give it a shot. So if we're going to deploy to the moon, we're going to need to have a Anthos cluster on the moon. So let's see if we can get that done. If I go to clusters, let's see which clusters we have. Well, I didn't see this before. There is a lunar cluster. Oh, okay. Let's see if we can. Oh shoot! Let's do a deployment. Let's run a deploy, and then we'll go. Yeah, probably. LuniChat Cloud seems good. We'll get that deployed. And I don't need any other functions. This is live help here, and then probably got to name it something like this. Seriously, is a moonshot. And then we got to pick which cluster it goes to. Oh, it says lunar cluster. Okay, everybody, let's give this thing a shot. We run deploy. Yeah. Oh, it seems like it's gone. Creates a deployment. We've got a cluster on the moon. Maybe this will work. So it's made the deployment. We're waiting for all the pods. All right. You should, here's the problem. Let's go look at Looney Chat. I bet you that it doesn't work because I go here. Yeah, see, bad gateway. We have to expose the service. we are exposing the service to the cloud. Oh, okay, here we go. So actions, expose. I got to put it on port 8000. We're doing this as a load balanced app. We expose it. And then we gotta edit the load balancer service. So hold on, one more piece to do. First bit, let's see, make a little change. So right here, if you're looking at the cluster IP, that's not quite all. We also need to know the location of the load balancer. So we can go load balancer IP. This is the address of 168.53.101 of the load balancer we'll use. We'll save that. And then we'll get, okay, now we're all green. If I come back over here to the bad gateway, refresh. Oh, we have Looney Chat. Okay. Well, let's send a message to the aliens. What do we want to say? How about we say, well, we got to log into that thing first. So hold on a second. Where is that password? There we go. So, okay, look, we got to send a message to the aliens. If I go like, yo, aliens, Anthos will work there too. That sounds like it's got panache to me. Submit this. Let's go back to our live stream. Hold on a second. Oh yeah, it's on the moon. Yeah. What was the ancient alien guy talking about with the aliens, though? What do you mean? Oh my God. Oh no, there are aliens on the moon. Oh, we have problems, ladies and gentlemen. Ladies and gentlemen, we've made first contact on a live stream demo from SADA. I'm super excited about this. Maybe Anthos isn't the most exciting thing on this. Maybe it's more about aliens. I don't know. I'm really, really happy about being able to present the advantages of Anthos to you on our platform. Super excited about your follow-up together with SADA and engagement with your customers and with your opportunities. Eager to see how you can make a big impact with this great technology. Thank you so much.